7, one of the things we notice is if you kind of look at how it's written, you can tell 1/5 is a fraction that goes together if you look at it in the book, can't you? So I got a number divided by a fraction. Y'all may not have done this exactly this way before, but you've done something like it. If I had a fraction divided by a fraction, my brain kind of knows usually how to handle that. The reason it looks at this and is a little confused is because you may not be used to seeing just a number divided by a fraction. So what I can do is think, okay, if the bottom is a fraction and it's 1/5, so it is a fraction, right? Let's turn the top into a fraction so that my brain will recognize it a little easier. How can I turn -7 into a fraction? What would I do to it to make it a fraction? I can turn anything into a fraction by sticking it over 1. So that's what I'm going to do. So if I write it like that, now my brain usually recognizes it a little bit better. Do you remember from other years that if you have a fraction divided by a fraction, you take the numerator of the fraction, or the top part, which would be -7 over 1, and then instead of dividing by a fifth, we change it into multiplying by the reciprocal. What was the reciprocal from the other day? It was the flipped fraction, right? Okay. So instead of dividing by 1/5, I'm going to multiply by 5 over 1. We have fractions and we're multiplying. Don't we just multiply across the top and multiply across the bottom? And that just how we do them. Those are usually easier than adding and subtracting. What is -7 times 5 on the top going to be? -35, right? 35. And then 1 times 1 on the bottom is 1. So -35 over 1 is -35. So the key to kind of getting your brain to kick in here and notice, they kind of go, oh yeah, this pattern, I've seen it somewhere before, is to turn that if part of it is not a fraction, if I see there's a fraction in part of it, turn all of it into a fraction on top and a fraction on bottom. So there's something similar to that if you look at number, let's see, well I guess number 9 was like that. You want to go over number 9? Y'all want to do that one too? Okay, so 9 is similar to this. If you look at the way they wrote it in the book, it's -6, and then you can tell 1/6 is a fraction kind of on the bottom there, the way they wrote it. Oh, it's a -1/6 on the bottom too. So the bottom is a fraction, the denominator is a fraction, the numerator is not. So our brain kind of goes, huh, you know? So what we can do to make our brain kick in a little bit better is rewrite the numerator as -6 over 1. Make it a fraction also. Anytime you're doing math with fractions, it usually helps to have everything be a fraction instead of just part of it. And that's especially the case here. And on the bottom, I have a -1 over 6. Now, we might remember from 7th grade and even earlier than that what you do is you take you take your numerator and you multiply by the reciprocal of the denominator. So the reciprocal means just take that fraction and flip it, right? Bless you. So if I flip 1 over 6, it's going to be 6 over 1. And it was negative, so it's a -6 over 1. Now a negative times a negative is a positive, so I know my answer is going to be positive. I see that on the bottom I got 1 times 1, so I'm going to get a 1 on the bottom. What's 6 times 6 then on the top? Since 36, so my answer is just 36. Now, before the year is over with, you're going to get some really complicated looking formulas. One of them is going to be the quadratic formula. And the thing about formulas is when they have a subtraction sign, it's easy to get messed up on signs here. So here's what I recommend everybody do. If I have A minus 3B, see how I'm making a space to plug everything in with parentheses here? It can really help you kind of keep stuff straight. And then I go back and I go, okay, I had an A up here. It was a -3. So let me plug -3 in for A. B was -1. So I've got a B here and a B here. A lot of people would, just when there's subtraction signs, they think they've already plugged a negative number in somewhere and they just put like 1 or something in that blank. You've got to be careful. C is 2 and it's on the bottom here, and then D is 6 and it's on the bottom. Now, do you remember that I told y'all that we call it PEMDAS, but a lot of people call it GEMDAS with a G because a grouping symbol can be a lot of different things. And when you have a fraction, one of the ways you need to look at a grouping symbol is the whole numerator is grouped together, and then the whole denominator is grouped together. You don't want to go try to, especially when you got these subtraction signs and adding signs on top of a fraction, you don't want to just kind of start going willy-nilly crossing stuff out. You got to be real careful. So let's look at the top first. -3. What's -3 times -1? Because I'd have to do the multiplication first. That would be a +3, So I'll put +3. And on the bottom I've got some other stuff. What is -3 plus 3 on the top anyway? 0. Yeah, 0. They add up to 0, don't they? You know what? No matter what I get on the bottom, isn't the answer going to here be 0? If you get 0 on the top, 0 divided by anything is 0. Do I really have to do the bottom here, the denominator? No, I could if I wanted to, but right now I can already tell you the answer is 0, and I could stop and not put any more effort into that if I wanted to. If it makes you feel better, just to make sure nothing weird happens, -1 times 2 is -2, and -2 times 6 would have been -12. It still would have been 0, though. So a lot of times when you're evaluating things, if you start seeing a 0 on the top, you might as well just stop and put your answer as 0. You don't have to waste any more time. Do is start on the left-hand side and show that it is equal to A over C minus B over C. I can't start out and just do stuff to both sides of that. I can only start on the left side, so I'm going to write A minus B over C. They give us some hints in the directions there. They say if you go look up at 34, we did one like it on 34, it might help you get started. So how am I going to make this A minus B over C look like A over C minus B over C? How can I prove that it's always true? When I do this with all these letters in it, it's actually proven that it's true for any numbers I stick in here. Well, here's what they do. If you look back up at 34, they're going to separate out the numerator and the denominator, because a fraction is really just division, and division is the same thing as multiplying by the reciprocal of the number in the denominator. So that's what they're going to do first, is just separate that out. You're going to find that that's going to be a handy trick sometimes in a lot of math problems, the harder math you get into. So I can do that because that's just the definition of a reciprocal or the definition of division. Either one of those would work there if you were given a reason. Because usually when we do these things, we have to tell why we can do it. Why is it true? Well, I can separate it out that way because a number divided by another number is the same thing as taking the numerator and multiplying by the reciprocal of the denominator. Now, the next thing you would do is why can I do this? Why can I say A minus B times 1 over C is equal to 1 over C times A minus B? Why is that true? Why can I switch the order like that? Is there a property that lets me do that when I multiply? Yeah, it is the commutative property. Remember that commutative property says I can switch orders? So if I were writing why I did that, it would be the commutative property out here to the side. They had you write it up there on 34, and they really want you to follow that same kind of format down on 35. Now, if I look at what I have here, I have a number sitting in front of parentheses, don't I? What does that look like when you see a number in front of parentheses? What property should kind of come to your mind? It starts with a D. There you go, distributive property. The distributive property says if I have a number sitting out in front of parentheses, I can multiply that out, can't I? I can say 1 over C times A. Wouldn't that be A over C? And then I could say a positive 1 over C times a negative B would be a positive times a negative is a negative, which I'm going to write as a subtraction sign. 1 over C times B is B over C. That was just the distributive property. Hey, I'm done, aren't I? Didn't I just turn this left-hand side into this right-hand side? Yeah, that's what they wanted me to show right up here, isn't it? And these properties right here tell why it's okay to do that. When I see something like this and I got to plug stuff in, I know I still got to be thinking about PEMDAS, right? Because there's a bunch of stuff going on up here. There's subtraction, there's multiplication, and there's division, right? So I know I need to be thinking about PEMDAS, and again, maybe calling it GEMDAS for grouping symbols might be a better thing, because that might remind me that this fraction bar is a grouping symbol. It separates this problem into the top all goes together and the bottom all goes together. And I need to take care of all the top before I do all of the bottom. and put them together. I kind of do them separately, then I put the whole picture together. Okay, so again, one thing I might do is A times B times C. That's my whole top part that I'm going to look at together. And then 1 minus C times D here. I'm going to make spaces to plug stuff in, and then I'm just going to go stick everything in there. My A was here, it was -3. B is -1, it was right there. And then your C was in two places. You had a C here and a C here. And then your D was 6, and it was just on the bottom. So I'm just making places for stuff and sticking it in. And I remember that I'm supposed to do the whole top before I do the whole bottom. Or it's not that I have to do the top first. I could do the bottom first. I just don't want to put them together until they're each separately simplified. Let's start with the bottom just since we can, okay? Because that grouping symbol is the fraction bar. If you look at the bottom, here's what you really have. You have 1 minus 2 times 6 if you kind of take out all those extra parentheses I had there for plugging in. And PennDOS says we do parentheses first, so I should take care of that 1 minus 2 before I multiply by 6. What is 1 minus 2? Isn't that like -1? If I have $1 and I want to buy something that costs $2, maybe you got $1 today and you want to buy some popcorn. How much short are you today? $1, so it's -1, right? And then you multiply by 6. So on the bottom, I'm going to have -6, right? But since the fraction bar is a grouping symbol, now let me go take care of the top. What I really have on the top is just all that stuff multiplied together. 3 times -1 times 2. Well, 3 times -1 is -3, and then if I multiply -3 by 2, I get -6, right? So I have -6 over -6. Anything over itself, no matter what it is what? 1. Okay, so you can just write down 1 if you remember that, or you could think about reducing it this way, because since I've simplified the top and the bottom, now I can kind of put the pieces together. -6 goes into -6 one time, and -6 goes into -6 one time, and 1 over 1 is 1, right? Okay, so I messed up and I didn't write it down. I wrote it up here and then I didn't copy it down right, did I? I left off the negative off the -3. So a negative times a negative on top, a -3 times a -1. If we back up to right here, a negative times a negative would have been a +3, and a +3 times a +2 would have been a +6, right? Thanks for catching that. I still would have -6 on the bottom, right? So I would have had 6 over -6. Let me just kind of cross this out since it's kind of messed up. Now I could say 6 goes into 6 one time. 6 goes into -6. Okay, a negative divided by a positive is a negative, and 6 goes into 6 one time. Positive divided by negative. Do you remember when you got two different signs and you're multiplying or dividing, it's always going to be a negative, right? Two of the same signs, like two negatives make a positive, two positives make a positive, but one of each is going to be a negative, and 1 over 1 is 1.